Okay, everyone, let's look at the final exam last week. We have 6 questions. The first question about regression. Please check the textbook chapter 10.1, homework exercise 10.1.1 Q8. And here is the link. Here's the link. And the first sentence is per capita income in 1960. Thus, go to the question number 6. I found that someone misunderstood something. Homework exercise 10.1.1, and we are going to check question number 8. Per capita income. Question number 8. See, 4, number 5, number 6, number 7, and number 8. And check the title. Per capita income in 1960 dollars for European, blah, 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 like this one. That's correct. Okay, and what's the question? The question is, please use the mileage data. Not mileage, the income data. That's not mileage. That's last year. The income data for x-axis and for the y-axis. Please find the trend line formula or trend line equation. Y equals a number times x plus another number. How about r squared? Okay, let me show you how to do this. First of all, select a number 8. You can select numbers like this one, or select all of them and click copy. Then move to for example, you can move to here. You can create a file. Actually, that's why I always encourage you to answer it like this one. You can copy and paste it here. Okay, and next, select the range here, percentage here, and select the range. Okay, then insert chart. Then we can select if the default is not a scatter chart. You can select it, not the column bar chart, not the line chart, no, not histogram, no. What we need to select is only this one, scatter, XY scatter chart. Okay, then check the title, per capita income versus percentage in agriculture, and the title of x-axis, percent in agriculture. That's correct. The title of y-axis, per capita income. Okay, and we got it now. That looks perfect. And next, please use the chart editor. Click customize, and now move to series. And scroll down. Click trend line. Check the trend line. Yeah, see, if the line is not significant, you can enlarge the size. Change the color. Make it apparently. Okay, and next, chart editor. Then show R square value. Check here. Show R square value. Okay, and next is most difficult. How to get the formula or how to get the equation. Please type label. And again, let me show it. Let me do it again. Click label and click use equation. Use equation. Then we got the equation. Thus, the answer will be minus 17.5 here. Y equals minus 17.5 plus 1277 plus 1277, and the R square value is 0.959. Okay, so far any question about the question number 1? Good. Okay. If you have a question, if you are shy to ask $1, I don't understand the question. Can I ask you, but not in the line group or not in the classroom? Sure, you can make an appointment with me. I will be glad to answer the question. Okay. If no more question, let's move to the second question. The second question. Normal distribution and probability. Please check chapter 6.3 exercise, the homework 6.3.1 Q4. Let's click. And the title of the question, according to the WHO Monica project, the mean blood pressure for people in China is 128 milliliter mercury. Okay, let's check the question. Yeah, sure. If you get this one, for example, you can select part of the texts and copy, then move to the website as I gave you. Hold the control key and V. Hold the control key and F. F is for find, to search. Then we got a question number 6 again. That is homework exercise 6.3.1. According to the WHO, blah blah blah, like this one. Okay, here be concentrated with those value. First one, the mean. The mean is 128. The second key number, standard deviation, is 23 millimeter of mercury. Okay, there are 2 key numbers. The first number is the mean, 128. The second one is 22 milliliter per mercury. Okay, the first question. Probability that a person in China has blood pressure of 135 or more. Here, I encourage you to use a website. I gave you that. I also gave you the information. That's 9. I like this one. Okay, And now here is to calculate z-score. Z-score, okay. And how to do that? The first one, the mean is here 128. The standard deviation is 23. Type that. The population mean, that is 128. Okay. I'm going to send this website to you. Okay. Okay, and now what's the raw score? What's the raw score? Our target is 135. 135. Thus, please search 135 here. And yeah, sure, some of you did a good job and got the full score of this question, but some were not. So could you please follow my steps? Use the website, or you can type calculator.net about the z-score calculator. You can find this website. Is it okay? Yep, 1 minute you can type this. Then follow my steps. You can type, 23, mean population. Actually, it's a sample population, but here we consider it's a population mean. Actually, here is sample mean, not the population mean, but here, because the number is bigger now, then we can use the sample mean instead of to represent the population mean. 128, 23. And here, as the first question, we can type 135. Okay, please do it. 1 minute. Do it. After that, you can click calculate.
Okay, that 135 or more, but the answer of like greater than 135, so it doesn't count the 135 itself. So.
Okay, later. Do you mean if I click this? So what's your question?
Okay, the second one.
The second one?
Yeah. It says greater than 135, right?
Yep, yeah, right.
But it says here 135 or more.
Or more,
greater than. 135 should be included, right?
Actually, in this kind of case, that is not important to include the value of 135 or not. I know your math is very good, so you answer this kind of question. But actually, this kind of normal distribution is continuous number, and when we type that, we don't need to consider about 135 or more. I know, and because it's a kind of, here is the map, the diagram, then we can know that 135 is on this location. Yesterday I gave you oh, 1 minute please, let me show you the diagram. How about later? Then let me explain that first. Okay. I will call you. Okay, here, I know your point is here. Actually, the blood pressure of 135, the location as a normalized diagram should be close to the mean, but on the right side of the mean. Get it? And now the first question in our exam, the question is, what's the probability the blood pressure is equal to or greater than 135, right? That is the area of this one. And under this kind of situation, greater or equal to, it doesn't matter. Because 135, the value is not countable. And when we solve this kind of question, we don't consider the kind of condition. But generally, if we calculate how many integers greater than, for example, between 5 and 11, you can count greater between 5 and 11, 6, 7, 8, 9, 10. There are 5 numbers. Yeah, you're correct. But for calculating the normal distribution, we don't consider the symbol greater or equal. We don't consider that because the number is a little bit different. Get it? Okay. And now I send the notes, right? You got this picture. That's 9. I remember I sent a note. That's 9. Let me check my line. Yes, I sent this picture to you. And okay, let me explain what is about this one. What is this score? Who can tell me what is this score? What is this score? Who can tell me? What is this score? Who can tell me? Actually, this score is this. What does it mean, this score? This score is as long as your data, for example, the blood pressure, we can transform it, normalize it to be a normal distribution, and it's a pear-shaped distribution, and from the center, that is the mean. From the mean is symmetric. And what does it mean? This score is a location, for example, a height, a body weight, or a blood pressure 135. Where is the location? 135 is here, very close to the mean, but not the mean, on the right side, because the mean is 128 millimeter mercury, right? And now it's a little bit close to the right. And how about, okay, this score, okay, let me have one more explanation. Okay, forget this, go back. We know from the exam, from the question 128, and here's 23. Could you please try to type this location as 128 plus 23? You can type here. Can you tell me the number? Calculate the z-score. What's the number here? You can type the result of 128 plus 23. That will be 151. Please type 151 and tell me how about the z-score. What's the number of the z-score? If we type 151, it means mean plus 23. Who can tell me? Okay, who can tell me what's the answer? The z-score is 1. Whoa. Why? Not 0.1, not 0.9, not 0. It's 1. Okay. Who also get the 1? Okay, and I have one more question. If you type the number here, if the type number, the mean 128, the standard deviation 23. If we type 128 plus 23 multiply by 2, how about you type 174 and click calculate. Why 2? Why? I know the answer is 2, but tell me why. Okay, and click do one more test. Could you please type the number 128 plus 23 multiply by 3 and tell me and input the number here and tell me the z-score. Three times of 23, 3 times of standard deviation, $197. So how about the z-score of 197? Three. Why? Why 3? Why? Okay, one more question. After this question, I will shut up and I will tell you why. Okay, please do one more calculation here. If I type 128 minus 23, that would be 105. If you input 105, how about the z-score? How about the z-score? Who can tell me if you type 105, how about the z-score? Who get this answer? If you can type those numbers, then I think you will learn the real meaning of this one. You can completely understand what the z-score is. I believe. Okay, who can tell me how about 105? 105. That will be -1. Why? Did you observe that if I type the mean minus the mean minus 1 standard deviation, the z-score will be -1. If you type the mean plus 2 times of standard deviation, you get the z-score as 2. 3 times of the standard deviation, you get a z-score of 3. Do you realize the truth? Honey? Actually, let me explain this. Oh, actually, as a normal distribution, oh, sorry, my hand drawing is very horrible, but I think you can understand this. Okay, and here's the mean. In the normal, that is 128 millimeter of mercury, but after normalization, here is 0, and here is 23 about the blood pressure. For this one, we can plus 1 standard deviation plus the second standard deviation plus the third standard deviation minus 1 minus 2 minus the third standard deviation. But if we change the number to the normal distribution after normalization, here is 1 standard deviation, here is the second standard deviation, and here is the distance is 1 standard deviation, but in the left side we call it minus 1 standard deviation, minus 1 more standard deviation. Can you get it? Can you get it? What does it mean? In the beginning, the blood pressure, the mean is 128. The standard deviation plus that is plus 23, plus 23, plus 23. All to the left side, minus 23, minus 23. And the area here is the population. Here is the location. And now we think about the probability. The probability is about the area. Okay, let's move back to our question. The picture, I drew this picture last night. What does it mean? Based on the mean 128 and the standard deviation 23, the number 135 equals 0.30435 of standard deviation. Not the 1, because 1 standard deviation is 23. This one minus 128, not a full standard deviation, it's just 0.3. And the location from the mean close to the right. And now we want to know the probability X smaller than 135. That is the area after this line, the area on the left side of this line. Is it okay? And in our question, what's the probability equal to or greater than 135. It fits this one. It fits this one. So the probability 0.38043. Here is the answer. Get it? Okay, then let's move to the second question. Second question, blood pressure of 141 or less, and we can go back here. The same, the mean 128, standard deviation 23, and the 141, type 141, and click calculate. And the z-score is 0.5. 0.5. What does it mean? It's greater than the mean, but not reach the one standard deviation. Okay, and the question is the probability smaller, equal to, or less, and we will pick up this one. Here is the answer. Because from this line, the location is 141 on the right side of the mean. And now we need to know the probability. The probability is the area in the left side. Actually, this computer helps you a lot. In the past, when I was a graduate student, we need to check a table, check a chart, then calculate that. But now, just click, you can get the answer. So you are easier to get the answer, but you need to realize what does it mean. Again, the answer for the second one is 0.71401. Any question? Okay, and the third question is a little bit difficult. The pressure between 120 and 125. 120 and 125. Can you get it? Can you solve this problem? Okay, let me tell you how to calculate this. First question, oh, sorry, my hand drawing is horrible. Oh, this one much better. Okay, and now we will know. Okay, my question is, we know the average is 128. The average is 128. And now we want to know the 120 and 125. 120 and 125. So are those two, where are those two? On the left side of the mean or on the right side of the mean? My question, 120 on the left side or on the right side of the mean? Left or right? Choose one. The center is 128. 120 should be on the left side. How about 125? 125 is less than 128, below the average. So those two are on the left side. And now we can expect that Here is 128. That is the mean. And now we want to know that assume this one is 125 and the how about this one? Black one. This one, oh sorry. Sure, it's a little bit exaggerate, and so it's very easy. The answer, the question asks us to find between those one, between this area, between this, how to get this one? How to get this one? Very easy. The area of smaller than 125 minus area smaller than 120. Get it? Okay, so you need to calculate it twice. First one, $125 and calculate. For the 125, the z-score is minus 0.13, and the area here on the left side, there is 0.448. They write down here. Minus another one. The area is here. And the area, the first area minus the second area, we got the answer is here. So the third answer is here. Between 120 and 125, the probability is 0.08412. Okay, so far any question to solve this problem? Now, if no more question, if you have a question, you're welcome to discuss with me. 1 minute later, we will move to the next question. Okay, let's move to next. And here, question number 3, paired t-test. Paired t-test. Sure, if you use the website, you can get it very quickly. And let's move to the question number 7. Question number 7. Homework exercise. Question number 7. Number 7 is here. To determine if Reiki is an effective method to treat pain, a pilot study was carried out, or blah, 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 like this one, and please check it and test at 5% level. Please check this one. And copy. Okay, and now the question is, first question, how about the number n? And the second one, the mean of two decimals and standard deviation. Remember, denominator is n minus 1. It means a sample standard deviation, not a population standard deviation. And after. So how about the number? The first, here is 7, here is 4, 26 minus 4, that 22 plus 1, 23. Thus, the answer here is 23. Okay, how about the mean? Click here, type equal. Average from A4 to A26, yeah, that's correct. And the second one, the same way. B4 through B26, okay. That's here, 9.1. Okay, thus the second, the answer here, the second area, share two decimals. The answer here, mean of two decimal, before that is 4.17, after 1.91. And the second question, standard deviation, click equal. CET, standard population, no, sample here. A4 through A26. STDEV. Okay, so the second question, standard deviation. To two decimals, that is 2.1, 2.02, 2.10, 2.02. Okay, and how about the degree of freedom? Degree of freedom, we compare that together. So that's 23 minus 1. Here's 22. Here's 22. How about the p-value? p-value. P-value, if you use this one, is not easy to calculate. I will suggest another one for you. Yeah, you can use this one, t-test calculator. And now remember, the question here is paired t-test. What does it mean paired? Before the treatment, after the treatment, the scientists want to understand whether the Reiki can effectively release the pain. So one patient or one person after the treatment, they can compare the difference. That's using paired t-test. Paired t-test. And first one, enter up to 50 rows. Enter all paste up 2,000 rows. I can paste up here. And second one, unpaired t, no. Which is unpaired? No, we need a paired t-test. I'm going to send this to you. Before and after. Copy, paste. No. And copy. And paste. Okay, and calculate now. Okay, we got the information here. Sure, you can use this one. The mean 4.17. The other one, the mean is 1.91. Sure, we get the answer here. Actually, we get the answer here. But you can use this calculator. It's easier. And degree of freedom, that is 22. That is 22. And how about the p-value? The p-value is here 0.0001 or less than that, and it's a significant a result to say yes, this treatment is very significant to reduce the pain. Okay. Do the data show the Reiki treatment reduce the pain? Yes. Yes. The answer is yes. Okay. Any question about this? Any question? Okay. 1 minute later, we'll move to the next question. Yeah. Okay. Student who yet to get your test paper, come here. Come here. Yep. Okay. Your serial number, last 2 digits. 009. 009. Okay. 1 minute, please. 009. Okay. 1 minute, please. I will check it because I will. Let me see. Okay. Next. They come first. They come first. Yeah. Serial number. That's 43. 43. 43. Everett. Okay. 43. 1 minute, please. 43. You see the number? 70. 70. 17. 17. 17. 17. Okay. Okay. Who yet to get your 47? 47. 47. 47. Nope, not this one. 47. No, not essential. No, not you. Your serial number. Your serial number. No. They just they come to ask the exam paper. You don't need to have them. But if they want to know score, they can lie me. Don't worry. Don't worry. Okay. Any question? Okay. How about a 5-minute break and then we will move back to our question? Is that okay? 5-minute break.